Problem 1, section 1.8, intermediate value theorem. Suppose a function f is continuous on closed interval 0 to 1 except at point 0.25, and that f at 0 is 1 and f at 1 is 3. Is it necessarily true that the conclusion to the intermediate value theorem will hold? Actually, answer is no. Conclusion of intermediate value theorem will hold if your function is closed throughout from closed 0 to closed 1. You shouldn't have any point of discontinuity. For example, here is a function which is constant from 0 to 0.25, value 1. At 0.25, there is a discontinuity and you have a step, a jump discontinuity. Height is 3, constant until 1. So you see this function goes from height 1 to height 3, but none of the intermediate heights can be achieved by your function. Alright, for example, 2 is here. There is no point here which gives me height 2 or 1.1 or 1.3, whatever. So you have only height 1 and then you jump to height 3 and there is no value, intermediate values are not hit. So no is the answer to this. Next problem. If fx is x cubed minus x squared plus x, is there a number c such that f of c equals 10? Okay. F x cubed minus x squared plus x is a polynomial, and polynomial functions are continuous on the entire number line, a real number line, negative infinity to infinity. In particular, my function f is continuous on closed 1 to 3. Note that f at 1 is 1, f at 3 is 21. You plug in x equals 3 and you get these answers. What does that mean? For any number, so what this actually means is, you might want to draw it to understand what it means. You have the y-axis and the x-axis, all right, and you have a continuous function. At 1, you have height 1, and at 3, you have height 21. Okay, that means you have point here and a point here. Now the question is, the point is your function is continuous from here to here. So we don't know how the graph looks like. Whatever it does, it has to start from point 1, 1 and go until point 3, 21. Which means, well, every height between 1 and 21 is hit. That's what intermediate value theorem says. In other words, for height 10, somewhere here is say 10, right? You should be able to find a number in the x coordinate, okay, a number in the x coordinate between 1 and 3, such that height at c is 10. That's what intermediate value theorem says. Is there a number c such that f at c is 10? Yes. Sorry. Next. Consider the function fx equals 3x cubed plus 4x squared plus 4. For what values of k does the intermediate value theorem tell us that there is a C? Okay, let's look at this one. Your function is 3x cubed plus 4x squared plus 4, which is a polynomial function. It's a polynomial function and therefore is continuous on the entire number line. In particular, my function is continuous on closed 0 to 1. 0 to 1. So what happens? F at 0, plug in 0 here. F at 0 is 4. F at 1, plug in 1 here. 11. So what this means is you have the same kind of drawing again, right? We don't know how our graph looks like, but what do we know? At 0, height is 4, correct? And at 1, somewhere here is 1, say, height is 11. Okay, so this point and this point. So whatever our graph does, for every number between 4 and 11, you will find somebody here in this region. All right. So for which values of k, can I find values here, right? From 4 to 11. All right, next. Determine whether the intermediate value theorem implies that this equation has a root on the open interval 0, 1. So because we are looking for a root here, you want to consider closed interval 0, 1 to begin with. Intermediate value theorem looks at closed intervals. Suppose fx is this function, right? It is polynomial, therefore continuous on the entire number line. In particular, it is continuous on the closed interval 0 to 1. When x is 0, I get 8.1. When x is 1, I get 1 minus 3 plus 8.1, that is 6.1. This tells me by intermediate value theorem, for every number between 6.1 and 8.1, we can find a C in 0, 1, open 0, 1, such that FC is n. But between 6.1 and 8.1, you cannot find 0. You cannot find a 0 there. Therefore, you are not guaranteed a root. Does not imply that the equation has a root. All right, next. From the intermediate value theorem, is it guaranteed that there is a root on this interval of this equation? All right, look at this equation. I'll move everybody to one side. So cube root x, moving it here plus x, moving this there minus 1 is 0. So the left hand side is now a function. Okay, fx, this is a cube root function and this is a polynomial. Polynomial is continuous everywhere, so is cube root. In other words, f, which is sum of a continuous and a continuous function, it is continuous on the entire number line. In particular, the interval -1 to 0. I'm going to take closed because I want to evaluate it first. So what happens at f at -1? Plug in -1 for x. Cube root of -1 is -1. -1 and a -1. So that's -3. Now plug in the other endpoint 0, 0, 0, negative 1. So what does it say by the intermediate value theorem? For every number between negative 1 and negative 3, there is a C in open interval negative 1 to 0 such that FC is M. But between negative 1 and negative 3, sorry, between negative 1 and negative 3, you will not find a 0. So there is no root N. All right. So I'll stop here with this video. Next video will continue on problem 6. Until then.